Today we are going to learn basic laws of probability. So if you know some laws of probability, it will make it easy for you to understand the probability and calculate the probability. There are many laws in probability. We will learn few of them which are very important. First of all, you have to learn addition law or additive law. Okay, this is addition. Suppose we have two events A and B. You can see in the Venn diagram two events A and B. What is the probability? There will be either A or B. So we can write as a union probability of A or B, probability A plus probability B minus probability A and B. So this is addition law when there is two events A and B. So probability of occurrence A or B, we can do like that. So you can see it is probability A union B, A intersection B means probability A and B, that is they are happening together. And probability A union B means probability A or probability B or probability A and B both. Because for the A we have the A and B, for the B we have the A and B. So we have to minus one time probability A and B. So probability A or B means probability A, probability A, B or probability A and B. So this is the addition law. We can use it. So when there is a question either A or B, we have to use the addition law. Probability A plus probability B minus probability A and B. So this is the addition law. Let us do a simple example. So there is a calculator manufacturer company. They found 5% of the calculator do not have memory button. So normally in the production process, there will be some default, and they found 5% of the calculator do not have memory button. Okay, that is they say for the memory button, and 3% do not have log button, and also found that 1% do not have both memory button and log button. This is the manufacturer company found that 5% do not have memory button, 3% do not have log button, and 1% do not have both button. Okay, so a calculator selected just to know how does that happen, and what is the probability that the calculator does not have a memory button or a log button. Then this is the question, the calculator do not have memory button or log button, then you have to use the addition law. Okay, so let us denote A for the do not have a log button and B for the memory button. So it is given that, so probability of memory button do not have memory button, it should be not memory button. Probability of A 5% is 0.05, and not log button, you can write not, I can write shortly, not log button, that is probability B 3% 0.03. So not log button and not memory button, you can write, there is some, so not log button, not memory button, we can write probability A and B is 1%. So it is given in the question, 1% of the calculator do not have both log and memory button. We can write like this, 1% means 0.01. So according, we know the addition law A or B, that is when there is a or, probability A, probability B minus probability A and B. So we can write probability not memory button or not log button. Okay, so how can you write the, as it is or, you have to not memory button plus not log button minus not memory and not log button. So you can use the addition law. So probability of not memory button, you have 5%, 0.05, not log button 0.03, and both do not have memory and log button 1%. So if you do the calculation, you will get 0.7%. That is 0.7, which is 7%. So if you select a calculator randomly from the production, there is 7% chance that calculator may not have log button or memory button, or maybe the both. Okay, so this is the meaning of addition law. So you can do this. Okay, now let us go to the another thing. So addition law sometime, so here we have a and, so calculator have both memory button and log button, and they can happen together. Sometimes even A and B cannot happen together, they are separate, they never ever cannot be happen together sometime. Okay, so you are a student of a department, suppose M&S department, you cannot be same time student of CSE department. So either you will be a student of M&S or CSE. We have the two programs, maybe two major, but you cannot be student of two departments. So they, it means mutually exclusive. When they both are separated, they cannot happen together. So in the example, a calculator may not have lock button or memory button. It's possible. You may be student and maybe a job holder. It's possible, but you cannot be student in the same time of two departments normally. But maybe mistakenly sometime, but normally you cannot be a student of two departments together. Okay, we may have two double major, but this is called mutually exclusive. When we have mutually exclusive, we can write probability A or B, simple probability A plus probability B. So this is the mutually exclusive. Sometime exam may come. How we can say understand mutually exclusive? When there is probability A and B is 0, they cannot happen together. They are mutually exclusive. Okay, remember this. So let us see on example. There is a ball. There are few balls in a from there are boxes. In the box there are few balls. 6 is red ball, 4 is white ball, and 5 is blue balls. Okay. So total number is ball is 6 plus 4 plus 5. It will be 15 balls. Okay. So one ball is drawn random. So it will be one ball is drawn at random. One ball is drawn, D-R-A-W, and one ball is drawn. So find the probability the ball is red ball. So how many red ball we have? Total is 15 we got. We have, there is a 6 red ball. So 6 over 15. So this is a simple probability. And what is the probability of that? The ball will be a white ball. There is 4 white ball, 4 over 15. And what is the ball? Is blue ball? There is 5 over 15. So if the question is yellow ball, there is no yellow ball. Okay. So if I give the question, the ball is yellow. Okay. Probability of yellow ball. So probability, suppose I give the yellow ball. Okay. Yellow ball. Because there is no yellow ball in the box, so probability will be 0. Remember that something is impossible in the probability, that will be 0, and something certain 100% chance, that will be 1. So something impossible not in the given, so that will be 0. Remember that. Okay. Now question number 3, the ball will be red or white. So here is the or we have to use the union. Probability red plus probability white minus probability red and white. So additional law we can write when there is a or, A plus B minus A and B. A is red ball. We got it. Red is 4 over 15. That is 6 over 15. You can write that is becoming 0.04. And white ball we got it 4 over 15. We got it 0.26. And minus red and ball. So two ball cannot be. One may be the red ball, one may be the white ball. They cannot have both color in a ball. Okay, simple. In one color ball, they cannot have both pen. So you have a pen, it cannot be two colors. Normally one color. It may be blue color, red color, or green color. It cannot have one color in a one nipple. So sometimes they cannot happen to. It should be 0. So if you do it, it will be 0.66. So probability of red or white ball will be 0.66%. Okay. Now there is another law, sometimes important, that is called complementary law. That is not A. Probability of A plus probability not A always 1. Something will happen or will not happen will be always 1. Then you can find probability of A is equal to 1 minus probability A. Or probability A will be 1 minus probability not A. This is called complementary law. Sometimes is important, but you should know not mean 1 minus yes. So there is a question. There are two components or two tests, test A and B, they are independent. So the probability of passing A is 0.065 and probability of passing test B is 0.095. So what is the probability the component will not pass A and probability will not pass B? So we know, so probability not pass A, 1 minus pass A, 1.06 to 35, 0.35, 35% chance, that is the component will not pass test A. Similarly, not pass B, not B, 1 minus B, 1 minus B is for passing is 1.9.9, it will be 1, 0.1, the 10% chance, that is the component will not pass test B. So this is the complementary law, we can do it. Okay. Now there is another important law in statistics or probability, that's conditional law. Conditional law mean we are giving some condition. There is some condition, conditional law, it becomes smaller. Suppose somebody going to attend the class. So anyhow, whether it is rain or not rain, every day he is going to the class, doesn't matter. But if I give the condition, he will attend the class, condition no rain. So the weather will be good, no rain, that the student attend the class. So I am giving the condition, sample space becomes only there is no sunny day, when there is no rain, the student will come in the class. So here we are giving the condition. Condition means it becomes smaller. So similarly, how can you express in probability? The probability, suppose two events A and B. So condition law is denoted by this bar. Okay, remember that probability of this will be bar. Okay, so this should be the bar. Okay, so A condition B, that is A given B, that probability of A, that is B is there. So we have to find the probability of A, condition B will be there. So B cannot be 0. That condition should be there. So somebody attend the class, condition no rain. Somebody attend the class, condition sunny day. So only sunny day that the student will attend the class. So this is condition probability of A, condition B. A probability of A given B. So all are probability of A if B is there. So many way we can write it A condition B. So remember that A condition B, A, there is a bar. Okay. So A given B. How can you make it simpler? Condition, you can make it without condition. Okay. This part is condition of probability A. Condition B, we can write probability A and B divided by probability B. Similarly, probability of B, condition A, that's probability of getting B, condition A is there. So how can you get probability A and B divided by probability of A? That is, A will be there. Okay. So remember the first one, we want to find the probability, and second one is the condition. Okay. First one, probability of B, condition of A. A is occur. So B cannot be happen without A. Remember, A cannot be happen without B. So this is the sometimes if friends give the condition, I'll go to the class if my friend go to the class. Okay. So sometimes I will take the section if my friend get this section. So there is a condition, not independent. They are condition, depend on the condition. This is a condition law. Let us do a simple math. If you see the math, there is a mathematics. There is a bowl or box contain two. There is a one white ball and two gray balls. A ball or number is 1, 2, 3. So we give the white ball 1 and gray ball 1 is 2 number and another number is 3. So this is the given in the question paper. So there are 3 balls in a box or in a bowl. So 1, 2, 3. 1 is the white ball, 2 and 3 is the gray ball. So here we can do a lot of question. So a ball is selected. So one ball is selected from the from this. A is the even, the ball is the even number, and B is the selected ball is gray. Say we can give the event something we want to get, that is event. So even A is the number of the selected ball is even, and B is the selected ball is gray. So probability of getting the even ball. Okay, if you see the question is a little more easier. Okay, let me do it there. So, okay, so probability of getting the even number. So how even number ball. Okay, even number ball. So probability of even number ball. So there are 3 ball and even number ball is only 1, 2. The ball is number is 2 is even number. So 1 over 3. So even number ball is 1 over 3. Similarly, probability of getting the gray ball. So there is no number, no condition. So gray ball. How many gray ball in the out of 3 ball? 2 gray ball. 2 and 3. So 2 over 3. So probability of B even is the B is the event of gray ball. So 2 over 3. Remember, okay, there is no condition. Now the condition. So there is another number. I want to select a ball. The ball should be the even number and gray. The ball is the even number and the gray. So condition is here is even number and gray and okay together. It should have together. It should be a gray ball and even number. Okay. Out of 3 ball, I have to select 1 ball. There should be gray ball and even number. So there is a 1 ball is gray ball and even number. So 1 over 3. So you can see there is no condition. I have to select a ball which have both things. It may be it should be the gray ball and the even number. So there is only 1 ball is even number and gray. Out of 3 is 1 over 3. Now the condition law. So the selected ball will be even the even number, but if the ball is a gray. So from the gray ball you have to select a ball that is the number is even number. Okay. So my question number 3. What is the probability you will get a even number ball? Condition, the ball is gray. So now it has become smaller. I want to select a ball that the ball will be even number, but from the gray number above. From the 2 gray ball, I want to select the ball that will be the even number. So there is only 1 even number. So if you say out of 2 ball, 1 even number, 1 over 2. So this will be the directly you can do. But how we can do without the condition, using the condition law? So according to condition law, we know that probability A, condition B is probability A and B divided by probability B. Now the probability of getting even ball condition if the selected ball is gray. So probability of even number ball condition that is from the gray ball. So how can you write even ball and gray, A and B divided by gray? So what is the without condition? So remember, understand, when you are using the condition, the right hand side become without condition. We are selected from all the ball. So from 3 ball, you are selecting a first will be even ball, even number and the gray. So where how many one? There is a one even number, and it is also gray. So it will be 1/3. So we have a one ball that is even number and also in the gray color. So it will be 1/3. Okay, and the divided by probability of gray. So there is a gray ball out of 3 balls. There's 2 gray ball out of 3 balls. So it will be 2/3. 2/3. So if you do the sum up, it will be 1/2. So as we did before, as I told you, the conditional law making the sample space smaller. So I want to select a ball that should be even number condition from the gray ball. So even number from the gray ball. So there we are not, when condition, we are not consider all the sample space. We are condition the sample space only for the gray balls, not the 3 ball. So here one, so there is a one even ball out of 2 gray ball, 1/2. So if we do without condition, also coming the same thing. There is the other law that is called multiplication law. When their events A and B are independent, then you can multiply. Probability A and B, that is A intersection B, you can multiply. Only you can multiply when they're independent. If the 3 events A and B and C, probability A intersection B intersection C, you can multiply probability A, multiply probability B, multiply probability C. So even when independent, you can multiply. Otherwise, you cannot multiply. So there is a math. So there is a, we know, with the math, it's a component. For component, there are 2 tests, test A and B, and test A and B are independent. It is given. So the component passes test A is 0.065 and passes B is 0.909. What is the probability? Randomly chosen component will pass both tests. Okay, both mean A and B. So pass test A and test B, then it is given the tests are independent, then you can multiply. Otherwise, you cannot multiply. So probability A multiply probability B. So passing of test A is 0.065, multiply passing of test B for 0.9. So if you multiply, it will be 0.585. So there is 58.5% chance the component will pass both A and B. So when they are independent, we can multiply. Now let us do another important and interesting math. It will sum up all the math we did before, all the law, addition law, condition law, and the both the joint law, joint probability will consider. So there is a math, and this is the contingency table. So the cured and not cured for a particular medicine is given for a group of people. So somebody cured, somebody not cured. Also, the people are divided according to male and female. So one divided for the cured people and one the not cured people. So male and female. So this type of table is called contingency table. It is divided according to 2 criteria. One for the cured or not cured, and for the male and female. So there is this table is cost table or contingency table. So from here, how can you do the math? One person selected randomly from this experiment, or the probability person is cured. So cured, but I don't know the total. So we have to find the total, and this is the math. Person is the male, or person is male and cured. How can you do the math? First of all, you have to find the total. So let us do the solution together. So if you do the solution, let me come here. First of all, you have to find the total. So total number of male, if you do 20 plus 15, it will be 35. Total number of female, also 20 plus 10 will be 25 plus 10 will be 35. Okay. So we get the total for the male, 35 male, and female also 35. And cured, if you do the row, column, 20 plus 25 will be 45 is cured. And 15 plus 10, 25 is not cured. So if you do some 35 plus 35 will be 70, or if you do the cured and not cured, will be also 70. So there are 70 people in the group. So first of all, you have to find the total for the row, female, male and female, and you have to find the total for the cured and not cured. So this total, you got the 4 total. One for the male, for the row, one column is male, one row is the male, one row is the female. One column is the cured, one column is not cured. So there is 2 rows, 2 columns. So there are 4 marginal total. 1 marginal total for the male, 1 marginal total for the female, 1 marginal total for the cured, and 1 marginal total not for the not cured. So when you get the probability for the marginal total, that is called marginal probability. There are 4 marginal probability. So the person is cured. So 1 marginal probability of cure will be, so how many person cure? 45 out of 70 people. 70 people. This is the probability that the marginal probability the person will be cured, or simple person is cured. But if it is written in the question marginal probability, don't be afraid. It is the same as the cured person, but the name is the marginal probability. Similarly, we can find the probability, marginal probability the person will be the female. So 35 over 70. Similarly, we can find the person will be cured. We did it 45, 70. Not cured, 25 over 70. So this is the 4 marginal probability. If in the question come, find the marginal probability, so you have to do the marginal probability. And inside, see, if inside there is also 4 inside intersection, male and cured, male and not cured, female and cured, and female and not cured. These 4 are called join number. When you find the probability male and cured, this is called join probability. Also there are 4 join probabilities. If there is 2 row, 2 column, 4, there is a 4 marginal probability. Also inside there are 4 join probability. So male and cured, male and not cured, female and cured, and female and not cured. These are the 4 join probability. So similarly, question number 3, the person is male and cured. Join probability male and cured. If you find 20 out of 70, okay. So male and cured will be 20 out of 70. So this is the join probability male and cured. And similarly, you can find the joint probability male and not cured, female and cured 25 over 70, female and not cured 10 over 70. So these 4 are joint. If you find the probability, these 4 are joint probability. Now question number 4, the person is female or cured. So this is the addition law. When there is a or, the selected person may be female or not cured. How can you do? We have to use the addition law. Or mean probability of female or A or B, female or cure, probability of female plus probability of cure minus probability of female and cure. Okay, just capital probability. So probability of female, we know what is the probability of female. Only marginal probability of female 35 over 70 plus, and only cure. This is also marginal probability of cure. Cure is 45 over 70 minus female and cure, joint probability. Female and cure, we have 25 female and cure. So 25 over 70. So this is the cure. If you do the mathematics, it will be 80, 60, I think 55 over 70. So this is the probability female or cure, 55 over 70. So this is the way. If a selected person is female or cure, that is maybe female or cure or female and both, it will be 55 over 70. Now let us do number 5. The selected person is cured given the person is male. So condition, the selected person is cured, condition the person is from the male. So from the male, so it is only from the male, not the total. So cure is 20, male is how many? 35. So 20 over 35. If you do directly, it is 20 over, you will get the mark. But how we can do the conditional law? How we can apply? The selected person is cured, condition from the given, the selected person is male. So how can you do? Cure, condition is the male. So how can you do? We have to write cure and male divided by probability of male. So cure and male from the total, how many? Cure and male 20 over total is 70. Okay. And divided by probability male. Only male the marginal probability 35 over 70. Okay. 35 over 70. So if you do the this, you will get it 20 over 35. So as I told, when you the condition law, it is becoming smaller. So a selected person is the cure, but from the male only. So cure 20 over 35. So 20 over 35. So if you do the condition law, it make it easier. It make it simple. But the answer is same. If you do, can directly, no problem. 20 over 35, you will get the full mark. 20 cure person from the male. So 35 male. So it will get the full mark. Okay. Now do the another math. That is the person is, the selected person is cure or not cure. Okay, cured or not cure. So or you have to minus probability of cure plus probability not cure minus probability cure and not cure. So probability cure, we got it. We know cure mean how many is 45 over 70 plus not cure, also not cure 25 over 70 minus cure and not cure. That cannot happen together. Cure is one column, another is a not. They have no intersection. They cannot have one person should cure, not cure. Any group that the person will belong. So we cannot write. They cannot happen together. Mutually exclusive. Let put 0. So if you do the math, it will be 70 over 70. So this is the total probability will be 1. So if you do the math, cure or not, similarly, male or female, they belong to any group, that will be also 1. Okay, this is the way for the contingency table. You can do the math. Please practice more and do yourself more practice. It will be easier. Okay, that's all for today.